We're going to do exercise 9. Exercise 9 is found in this drop-down box. So I'm going to choose exercise 9, and here in the text area on the right we have exercise 9. In this exercise we observe the necessity of taking a covariate into account to detect the difference between two treatment groups. Okay, so initially we're going to analyze a data set which is not influenced by covariate x1. And okay, so let's look at that data set. We'll find one by setting the slope beta 1 equal to 0. All right, so now you see the blue and the black lines are both horizontal. And let's let me set beta 2 equal to 40. Okay, so here x1 might still appear to be significant because you see the gray and the light blue lines, the estimates are not horizontal. So I'm going to resample, choose new, keep on hitting new sample until I get a B1 value that's close to 0, and I still want the model to be significant. So let me do that now. So after a few tries of hitting the new sample button, we have a B1 value of minus 0.01, so that's pretty close to 0, and our model is significant. In this situation, we really don't need analysis of covariance, since the covariate x1 does not appear to be significant. Really, we can just do a simple t-test to detect the difference between the blue group and the black group. So let's do that. Let's do the t-test. Okay, we can get the data values by hitting the display data button over here. All right, so here we have the black group and the blue group. We're just interested in the y values. All right, not in the x1 values, because remember we said they don't seem to be influencing the outcome. So we're just going to look at these y values. Here's the first group and the second group, and we'll do a simple t-test. We've opened up R in order to do the t-test, and I read the black group into variable y1 and the blue group into variable y2. And here's our t-test. Here's the t-test statistic, minus 3.16, and the p-value is less than 0.05. So we conclude that there is a difference between the means of the black group and the blue group. Now notice if we take this value and square it, we get t squared is equal to 9.99. Now let's take a look at our f-test again. Here's the f-test, and we have an f value of 9.04. That's close to t squared. Remember, t squared was 9.99. It's a little less, though. If we had done, instead of an analysis of covariance, if we had done an analysis of variance, we would get exactly an f value of 9.99, which is the t-test statistic squared. So the t-test, when in the case of two samples, is exactly the same as analysis of variance test. Now we're going to translate this data set so that x1 becomes significant. So we'll do that by dragging the blue diamond, or the black diamond actually, increasing the slope in our model. All right, so we'll keep increasing the slope. Here we reached, let's say we reach a value of about 1.8. Okay, 1.82, that's fine. All right, and now we want to see if a simple t-test like we performed previously will detect a difference between the blue group and the black group. Notice the F statistic of the ANCOVA model is still 9.04, so analysis of covariance, which does take x1 into account, detects the difference between the blue group and the black group. Nothing has changed. All right, but if we do a simple t-test, I'm anticipating that it will not be significant. To do a t-test on our translated data, we'll first get the data by hitting the display data button. So here we see we have the black group and the blue group. All right, now I read this data into R, so let's look at R. Okay, so here we have y1 is the black group and y2 is the blue group, and we did a simple t-test. Here's our t-test statistic. Notice that in absolute value it's much smaller than the previous test statistic of minus 3.1. And notice that the p-value, 0.07, is not significant, is greater than 0.05, so this test is not significant at the 0.05 level. Alright, so let's just go back to our graph, and that shows us that in order to detect the difference between the blue group and the black group at the 0.05 level, we really need to do analysis of covariance and take our covariate x1 into account.